Good evening, and thanks for joining our Tuesday night webinar hosted by Texas Instruments. Have you ever wanted your students to push their thinking past the answer they got, whether it was right or wrong? Well, tonight, our presenters have struggled with this and are really excited to share their thoughts and ideas. My name is Mike Houston, and I'm the moderator for this event. I teach algebra and calculus near Pittsburgh, where I use TI technology to make those tough to teach, tough to learn concepts accessible to all my students. I'm really excited to be joined by our two panelists tonight, Sherry Abel and Jan Michener. Sherry has completed more than 35 years in education and is currently spending her time consulting. She taught middle school and high school math for 28 years and taught a lot of stuff, including Algebra 1, Geometry, Algebra 2, Pre-Calc, Calc, AP Statistics. She's been a state transformation coach and has been a district high school math specialist. So she's definitely worn many hats over the years. Her passions include helping other teachers see the power in having students explore mathematics concepts through the use of technology, as well as helping students make connections between that math and the real world. So Sherry, it's great to have you with us.
Thanks, Mike. I'm really excited to be here. Super excited to share what we know.
And Jan has been a math teacher for over 35 years, again, teaching a wide variety of math courses, everything from Algebra 1 up through Calculus 3. Currently, Jan is a virtual teacher with Indiana Online Academy. She received the Presidential Award for Excellence in Science and Math Teaching and is an AP Calculus reader and has been with the T-Cubed organization since 2003. Her passion is mentoring and training teachers on using technology as a tool to enhance learning. So Jan, we're definitely excited to have you with us tonight as well.
Thanks, Mike. It's really great to be here.
Sherry, would you discuss some things that we hope to get to tonight?
Absolutely, Mike. Tonight we're going to really focus on, like Mike said, looking beyond the right answer or even the wrong one to see what are students thinking. And with that comes the knowledge that most of that thinking we understand and know from our students because of the feedback we get from them and the feedback we give them. So you'll notice that our agenda tonight focuses a lot around academic feedback and its importance, what it takes to set the stage to get our kids ready and comfortable with that, and then really kind of wrapping it all up with a tight little bow for you tonight. At the end of it, you're going to want to stay tuned because the exciting part of tonight is you will be in a drawing to win a handheld of your choice, a TI handheld of your choice. So who doesn't want to stick around to the end for that? That's what I've got to say.
Sherry, thanks so much. And Jan, would you talk through our expected outcomes?
Our expected outcomes for tonight are the following ICANN statements. I can model effective feedback in my classroom. I can create a safe environment that promotes student to teacher and student to student feedback, because that's what we're all about, is building those relationships with our students. And then I can effectively assess student thinking beyond the right answer, just making sure that our students are connecting to where they should be and connecting all the dots.
Jan, thanks so much. We're expecting a large crowd tonight, so your audio is muted. Feel free to send any questions that you have for Sherry or Jan using the Q&A window on the right side of your screen. We'll also be using that chat window tonight to send general messages. As a reminder, the session is being recorded, and we'll provide a link to the event certificate of attendance at the conclusion of the webinar. So, Sherry, you have control. Feel free to get things started.
All right. I'm so excited, you guys, to be able to present this to you tonight. We've done a lot of talking and a lot of planning around all of this, and we hope you're as excited as we are to kind of dig in to the student thinking beyond that right answer. And I know Jan is excited as well. So to get us started, like Mike said, we want you to be able to put all of your stuff in the chat. That's going to be extremely important to us tonight. So the really cool thing about this is we're used to being in an environment where we can like talk to you and you can like talk back to us. And then tonight it's going to be kind of Jan and I getting to talk a lot together, and you're going to have to chime in and chat, and we're counting on your participation tonight. So I hope you have some paper and your pencils ready. because we're going to kind of put you to work. So please, please, please actively participate tonight. We want your input and we're looking for your feedback as well in that chat because we're going to build off of that. So if you're ready, here we go. Here's your first question. Let's see what happens. I expect you to solve it. Put your answer in chat. And I know Jan is going to be
great.
all of those
Kathy.
answers.
Yep, Michelle's on it. There we go. Nice job, Matt. Oh, yes, Barbara, you got it. Lots of 9s. Look at all those 9s. Look at all those right answers. Oh my, that's great.
Wow. It sounds like we've got a really smart group tonight, Jan.
They're on fire. They're on fire.
Perfect. All right. Looks like we're ready to move to question number 2. So here we go. Ready, set, and we're on it. How about this one? Let's see if we can stump them on this one. I bet we can.
Here we go. Yep, they're just, yep, here they're starting to come in.
Wow.
Nice job. Nice job. All right. Nice job. Lots of different formatting. Good job on the creativity. There we go. Yep. Woo-hoo! We got this. Everybody has rocked it.
We haven't been able to stump them yet, have we?
Nope.
They must have eaten their Wheaties this morning. That's all I got to say. They've eaten their Wheaties.
Yeah.
All right. Looks like we're more than ready then to move on to question 3. I don't know if they're ready for this one though, Jan.
I don't know.
I don't know. We'll see. Here we go.
We'll see. Got a different format. What are the zeros of the following quadratic? They're looking. Nice job there, Michael, Kathleen, Peter, Kate. Nice job. Lori, way to get in there. Good job.
Look at all these.
Yes. Fantastic.
Whoops.
Somebody wants to change. Change an answer. We get that. Yeah.
Whoops. All right. So, wow, look at all these answers.
Nice answer.
Needless to say, all of our participants played the role of really smart students. And I'm sure that all of my students in my classroom would have gotten these right as well. Wouldn't you think?
I would think.
And I'm sure it's the same in your classroom too, right?
Right.
Everybody would have gotten it right. So let's talk about this. What I want to do is pull up, or we just copied our answers from the rest of them. Now, wait, what? Copy? Surely not. So we're going to dig into that second question that we sent you, and we're going to kind of talk through it because we took a look at the answers and we saw a lot of people who put 3 and -2, different formats of suggesting that answer. So what I did when I posed this question to a classroom of students is I looked at it and they pretty much all got the question right, as you did. But I went up to one student and I said, talk to me. Tell me exactly what you were thinking. How did you approach this problem? What did you do to get the right answer? And she, handy dandy, whipped out her Inspire and said, well, I actually graphed it and found the zeros of the function by looking at the places where the parabola intersected the x-axis. And I was like, okay, wow. Okay. 1, kudos for being able to use the tools that she could to solve the problem. But 2, I also knew from her terminology, the mathematical terminology she was using, that she truly understood what she was doing and what it meant to be a zero of a function. So by digging in behind that right answer, I could really readily see that she truly understands what it means to solve this quadratic equation. All right. So Jan, I know you had a different experience giving the same question to one of your students.
I did. So to set the background, in Algebra 1, how you start factoring and, you do factoring for weeks on end, it seems like, and then we switch over to solving those quadratic equations. And we always start with solving, at least I do, solve by factoring, just to show that transference of how we use that skill of factoring. I had a student who struggled a ton with factoring, and we spent a lot of hours together, and she was still struggling. So I knew she would struggle with this concept. And so we talked about it and I worked with her. And then she came back the next day during our warm-ups and she was on fire, just like what our chat room was tonight. She was just putting them out there quickly and getting them all right. And so I asked her, I said, I'm just so proud of you for being so successful. in your answers today. But you know, I want to know what clicked, what has clicked that has made you, you know, understand this concept or get these answers right. And this is what she told me. Well, here's what I do. I take the last number, multiply it by -4, then I add 1. Then I take the square root of this answer, change the sign of the middle number, add it to the square root answer, and divide by 2. And I go, wow. And then she goes, now you got to get the other answer just by doing the same thing, except you subtract. And so, you know, I was just like, I'm amazed, you know, and I'm sitting here thinking she's going through the quadratic formula. The steps that she's talking about are the quadratic formula, but she had no clue what she was doing. And I said to her, I said, you know, after, you know, we had a discussion, I said, well, if you take your method and you want to use it for another type of problem, for instance, what if I put the 2 in front of the x squared? Now I want you to solve that one. She goes, I don't know how. I could only do it if it looks like that problem you just gave me. I could only have a coefficient of the x squared to be a 1, then I know what to do. And, you know, without me asking her that, I would have just thought she figured it out. She now knows how to factor. She now knows how to solve. But because I asked her, what was your method? How were you getting those answers? I got a deeper insight to her, you know, her method, her lack of understanding the math behind what she was doing. And it helped me to understand that this student is never going to be able to solve by factoring. I'm going to take her and I'm going to coach her a little bit better on the quadratic formula so that she, you know, that's what she's reaching into. And there was no way I was going to tweak her step number 1 and tell her, well, if you would have multiplied the first number times -6, you could do your method. I would really, you know, I didn't want to go there. I wanted her to be a little bit more in tune with the quadratic formula. But once again, meeting my student with where they're at and figuring out where their background is and what their thought process is was huge in helping me help this student be more successful.
Right, Jan. I think it's interesting when you first shared that experience with me. I was like, holy cow, that's some little trick there, which we understand is the quadratic formula in a different, you know, squished around manner. But I love the way that you actually responded to your student. And it's because you dug in behind the correct answer that you realized that the student's light bulb hadn't come on the way that you thought it had. She was getting her answers correct, but because you dug behind that correct answer to see how she was now thinking about these problems that she had been missing, but is now all of a sudden getting all of these problems right, that you understood that she has some challenges here. That is the important piece. And the type of feedback that you gave her is great because you dug into it to see what are the limitations of what she does understand. And so you did meet her where she was, and you're providing her with the next steps of getting her to where she needs to be. So that's all about that feedback. So to hear from you guys, we want to get your ideas of what you think academic feedback actually is. So I know it'll take a second to type, but put your thoughts in chat. And you can just think of the theme to Jeopardy playing in the background or, you know,
Sherry and I can sing, you know.
Oh, yes, that I'm sure the singing part is what they are really after.
Oh, yeah. You know, we would always sing the quadratic formula, you know, to our school song. So
well, we also have the imaginary number song as well.
there we go. Yeah.
And that's very country. So
yeah,
you
well,
know,
they better start typing fast or we're gonna start
I know.
singing. Oh, here is one. Here's a very good what is academic feedback? Yes, but why? That's a good one. But
Okay,
why?
yes, but why? Great.
Helping students analyze their own work to help them achieve mastery.
A response to student work that ideally provokes further thought.
Feedback to move students forward with their learning. What are the
Posing
next
sound
steps?
questions.
Yeah.
Determining thought process. These are great.
I like this. It's specific to the student and the activity.
Ooh, okay. Comment on the students' work to be sure they are able to teach the information. I think I skipped down to another one.
So they're going through.
I know.
Yeah, written or
Give
verbal
timely
response.
feedback on mistakes and successes.
Mm-hmm. Feedback on the process, not the answer.
Mm. Getting students to reflect on their reasoning. All right, so we have a lot of great information there, a lot of feedback from you about what feedback actually is. Oh, I like to have students discuss problems with each other while I wander the room and ask questions of them. Great answers, giving students insights into methods they use and suggestions for improvement and encouragement. So let's see what some of the experts deem academic feedback to be.
I think you went too far.
Did I?
Yeah.
Sorry. I got excited.
There's a slide before this one.
Yeah, it's not going back.
Okay.
Oh, wait, I can make it happen. Look, ta-da, technology.
Oh, you're so good, Sherry. There we go.
So based on this, if you look at the Education Endowment Foundation, you can tell that feedback is exactly what many of you were saying in the chat it was. It's about the learner's performance. It's information we give to them or someone gives to them about their performance. Really, aligned to learning goals or outcomes and how to help them actually improve their learning. It's about their next steps. What can we do to push them further beyond where they are? It can come in many forms. It can be verbal or written and can even be body language. And girl, I'm telling you, Jan, many times I have to go, oh, watch your face, Sherry, because my face can sometimes give it all away. But it can be verbal or written, and it can come from a teacher or a teacher's aide, that inclusion teacher that's in the classroom. It can come from their peers. So it can come in many different ways. So much of what we saw in chat aligns exactly to what the experts are deeming what feedback actually is. So let's see if I can actually just advance one slide this time, Jan.
One slide is good. One click, Sherry, one click.
Hi. So go ahead.
Okay, we all know that feedback is important. Why is it so important? It's just an essential part of effective learning. I mean, students need that feedback. They need to get that confidence, that self-awareness, that enthusiasm for learning through that feedback that we give them, their peers give them, the feedback they give us. Feedback is more strongly and consistently related to achievement than any other teacher behavior. So think about that. Any other teacher behavior, feedback is the most important to help our students achieve. And it's just.
Go ahead. Sorry.
I just think of it as it's the building block of our classroom, of our learning.
It really is. And if you look at John Hattie's work, and he's done a lot around metacognition and doing all of his research on the different things that actually impact student achievement. And one of the things that impacts student achievement a lot based on his barometer is student feedback. It's feedback in general, and it has an effect size of 0.70. So if you know anything about Hattie's research, his barometer of influence says that 0.40 is the hinge point that determines when things begin to have a strong impact on student achievement. So you can see that feedback actually exceeds that by quite a bit. So that is really a why we need to be really good at giving strong, effective feedback to students, and why we have to be aware of how to elicit great student feedback back from them, and then how we can really ratchet it up to the next level for them and help them understand how to give each other strong, sound feedback.
So that's what we're going to talk about tonight is some types of feedback that we're going to have. It seems like the teacher to student feedback, that's what we were doing in that first slide, where you were just putting in some correct answers into the chat room, and we were only given teacher to student feedback. Great job. Good. Nice job. But we weren't getting any thought process back from that feedback. So when we are thinking about our types of feedback, our teacher to student feedback will eventually and hopefully lead to student to teacher feedback, where the student is giving information back to us so we can process the information of, yes, they're working that correctly, or no, they still don't have it. Take, for instance, my student. She gave me some feedback, and I was able to, start changing my instruction with her and helping her understand maybe a little bit better of the correct process, or a more sound process to figuring out the answer to her problems, or to the quadratic problems, not her problems. And then we have like student to student. We want to eventually get our classroom so that students can feel comfortable working with each other, giving each other feedback, critiquing each other's work, and start the conversation of getting that math skill at a higher level. And so that's the type of feedback we are going to be talking about today.
Right. And like Jan said, if she hadn't have dug into behind the correct answer that student had given, she would not have known that the student was really still struggling with the content, which was about factoring. So to set the stage for feedback, we're looking at things that have to really take place first in order for feedback to ever happen. And if you look at NIET's work, and that's in the National Institute for Excellence in Teaching, they have a rubric that actually has an indicator that is only about academic feedback. And it goes from teacher actions all the way over to next steps. But one of the things that they focus on is the classroom environment, which is so critical to a student's success. And in order for feedback to take place, the environment has to be safe. It has to be a mistake-friendly environment where students feel safe in sharing their thoughts, their misconceptions. They're okay with getting something wrong in front of their peers because ridicule isn't going to happen. So it's important enough for NIET to make it part of their rubric that we have to have that safe environment for feedback to actually ever occur. So we want to start off with creating a safe environment, really. And we like to start off with strategies at the beginning of the year where there are no wrong answers, that everybody can have a say and input. And although a lot of people know about which one doesn't belong, I think there are even greater numbers of people who have never really played with this in the way that we're going to kind of attack it. So you know the course, which one doesn't belong. I want you to throw into chat. Look, we already have people throwing into chat.
Yep.
Which one doesn't belong? And we're going to let you choose A, B, C, or D. So we see some things coming in. So remember, you have to participate because we are watching you, right?
Watching. Yep, we certainly are.
Oh, I had one in there, each of them for a different reason. Pi, D, a lot of D's.
A lot of
Some
D's.
A, C, D. Great.
There's some C's. There's some C's in there. Lots of
D's in
C's.
there.
This is interesting. I always start this with my students. Since I teach virtually, it's always very difficult to get students to communicate with themselves, with each other in our breakout rooms. And this is something that is very successful in my breakout rooms and getting students to discuss. And of course, the first time they don't know that there's not a wrong answer. So it's always interesting when we come back for class discussion on how they change their minds.
Right, exactly. So Jan, I'm going to ask you, if you were doing this, which you should be participating, which one would you kick out?
I would pick B.
Can you tell me why you would choose B? Why B? Because we had several in our participants that actually chose B as well.
I would choose B because it's the only one that's represented as a fraction in that set of four. That's why I would pick B.
Okay, so Jan picked B because it's the only one that is represented by a fraction out of all of them. And I would normally ask my whole class, if you chose B, did you choose it for the same reason Jan did, or did you choose B for a very different reason? And so usually that would wake up and have people say, oh, well, I chose B for a different reason, and it's because it's a repeating decimal that extends longer than D does. It takes 5 iterations before it's actually going to repeat. All right. So I might ask some students, I saw a lot of C's out there. Why would you choose C to be the one kicked out? And many of my students would say, well, I kicked it out because it's the only symbol and the rest are numbers. And that's okay. But I also saw one person who said, I put C because it's the only irrational number in the list. Well, now I'm getting at that student thinking, Jan. I can see that that one student has a little bit more knowledge about what he's looking at than my previous student who only kicked it out because it's a symbol. And I have a lot of people saying C is a symbol. I have a lot of people saying that they would actually kick out D for different reasons. One of my students actually said they would kick D out because it's the only one written in a decimal form with a bar over numbers.
Right. And they may not know what that bar over the number means.
Correct. But
they
that's
can
also
recognize that.
insight into their thinking. And so I always ask, is it possible that we could kick out each one of those? And somebody already put that in the chat. I could kick out each one of these for different various reasons.
Yes.
But we have to get by just A, B, C, or D and really get behind the why they are choosing what they are choosing. And remember, feedback is really anything that we say to a student and anything they say back to us is considered feedback. So if I want to get more feedback, then I have to ask the right questions to elicit those responses.
Exactly. Just saying A, B, C, or D with nothing
Oh,
else doesn't
Well,
really.
and Michelle, you're correct. D isn't a form that we've ever used as a representation of pi. So many people will actually say, many adults will actually say 3.14 repeating is not usually used as a representation for pi. And the other three are well-known representations of pi, right?
Right.
So just being able to provide something like this where students can all be engaged, all have a voice, all have a say without being wrong is a great way to begin to get students really liking the environment, being able to say what they need to say without the fear of ridicule, knowing that others in the room are thinking the way they did, and then others are thinking a little differently, but they're getting to listen to all of it. So another strategy I know you want to bring up.
Yep. I want you to look at this, Sherry, and I want you to look at this and just what do you notice? I would ask my students, look at this graph and just tell me, what do you notice? That's it. Give me one thing that you notice.
Well,
and let's put that in the chat room. Go ahead, Sherry.
Well, I was going to say, just besides the fact that the lines are a little curvy and not like very straight on the graph, I noticed that one appears to be steeper than the other. That's what I kind of noticed. Ooh,
Okay.
a lot of functions in the chat.
Now, Sherry, you said one looks a little bit steeper than the other. Now, how did you come to that conclusion?
Well, when I looked at it, I could say, like, I noticed that if I put a car up at the top there by 72 and let it roll down that slope right there, that I feel like it would go faster downhill than if I put the car on the second line up at 175 and let it roll down the hill.
Okay.
So that's what I was seeing. A lot of people are saying flipped axes, that they're noticing that time is on a different axis than we're used to seeing.
Yeah. Someone said a U-turn. This is a U-turn.
Right. We're getting a lot of great notices. So
Yes.
the point behind that notice part is really just to give students the ability to say something. And Jan, when I usually do this kind of activity, I will have the students hold up fingers in front of their chest if they notice one thing or two things or three things. They're holding that in front of their chest. So I'll know that if I only have a student that can notice one thing, I'm going to call on him first, so his thing doesn't get stolen by someone else.
There we go.
The opportunity to speak. So I'm sorry, I just wanted to put that in there.
That's very good. And you can tell I'm used to teaching virtually because I'm like in the chat room, give me one. And then teaching virtually, like, okay, do you have a second one? You know, is there something else that somebody hasn't said yet that we're seeing, you know? So you can tell I teach virtually when I say that in that form. And, you know, a lot of people were mentioning do we have two functions? The notice. Oh, maybe that's more of a wonder. So now we switch over to, what are you wondering? What are we wondering?
I wonder if the graph just ends right there at 200, like if the two things meet and the graph just comes to an abrupt halt.
Right.
Oh, did someone intend to have two separate functions on the graph?
That's a good
Oh,
wonder.
that's a good wonder.
Mm-hmm.
Wondering why time depends on the distance. Is
Very
this two
interesting.
events on the same graph? So the purpose of having a notice and wonder is to give students the ability to really jump in and be able to say what they notice and wonder, and realize that you're going to build your class discussion around this, the mathematics involved in this. And then by the end of class, you're going to come back and they're going to be able to interpret this graph based on the mathematics that you filled in around this graph. So notice and wonders are a great way to do this. As a physicist, I wonder why the grapher put the time on the y-axis. Interesting. So there's a lot about this that will get students very comfortable in your classroom with being able to say things and be right. But the thing that I would caution you against, if you have something with a lot of color, you're going to have students say, I noticed that the font is red and that the shapes are blue, which is fine. But what you want to do is what Jan did with me when I said the lines are curvy, but one appears to be steeper than the other. She asked for clarification about that. What makes me think that? And so if we're looking to help students understand that they need to use correct mathematical terminology, then we have to ask the right questions when they give us that notice or that wonder, and really pull from them what we want to hear or what we need to hear from them to get at their thinking. So the last one is a great one too, Jan. Did you want to jump into this one?
So this one it's very interesting that you give them the instructions first, so they know ahead of time what they're going to have to be doing before they can see the picture. So this is, again, another way of creating a safe sharing environment. Give them another tool or another activity just to be able to voice their opinion, be confident on what they're saying. And the more days that you can do this, the more time that you spent building this community in your classroom and building this safe environment will pay off so much in the long run. It is not time wasted at all. And so I do like giving the instructions first. So here's your instructions. Find the total number of circles without counting each one individually, and prepare to explain your shortcut. So there's the instructions. So I make sure everybody's
rip
prepared.
The Band-Aid off.
Rip that Band-Aid off.
Rip the Band-Aid off right there.
Okay, everybody look at it and think about how would you find the number of circles without counting them, without counting. And I think in this actual activity, the process is better than the answer. You know, the process I feel is more important than the actual answer.
All right, so I have some people that have put in the chat 3 rows of 5 followed by 4 rows of 2 to get their answer. I saw 3 times 5 plus 4 sets of 2, and rectangle plus 2. And I believe that person, that's the way I kind of saw it. And I don't know, I'm going to point at my screen, so that's very helpful, isn't it? So I don't know if you can see my cursor.
No, we cannot.
Okay, perfect. So the 2 top towers.
Oh, wait, maybe we can. Try that again, Sherry.
Can you see my cursor?
Yes, we can.
All right, so take these 2 little guys. If I take this set of 2 and drop them right here, and take this set of 2 and drop them right here, then I can see that I have 3 rows of 6, right? Or 6 rows of 3. That's what I have. It's been a long day. 3 rows of 6 is what I have, right? All right, which gives me 18.
No, I think you have 7.
1, 2, 3, 4, 5, 6.
7 rows.
7.
Oh.
21. 7 rows of 3. And then I have these 2 guys sitting right here, which would give me 2 more or make it 23.
Yeah.
So taking these 2 guys, sliding them down, having that rectangle, and then these 2 guys being the extras. But we did see a lot of people that saw this, and then 2, 4, 6, 8 more, right?
Right.
So 15
right.
plus 8 more columns, not rows.
Actually, I think that's the way, that's when I first saw it, Sherry, that's what I thought of. Take the inside rectangle that's already constructed and then add the others that are floating around.
Yes, exactly. So again, these types of shapes, what I've done with them, they have a bunch of these at the Fostering Math Practices website. And I paste them around the room, not paste them, tape them, because I would, they would hang me if I actually like pasted them to the wall. But I hang them around the room, and I actually put students in pairs around the room. They all have different shapes. So then when we have that class discussion, everybody's getting to share their thoughts about their shape. And it's more of a gallery walk for our students. And that's so much fun, but it gets them out of their seat. It gets them thinking and talking to each other, fostering that collaboration. So the website is fosteringmathpractices.com. All right. So contemplate then calculate is a lot of fun because it does require students to think and that spatial reasoning, but it also gives them time to collaborate and share their thinking. And what I heard in my classroom was the fact that kids would go, oh, wow, I didn't see it that way, because they were learning from their peers how other people saw and looked at this shape and determined how many without counting was different than their own. And that's always eye-opening, that they can admire their peers for actually seeing something that they didn't see themselves. So if we're looking at it, we've got to look at what the characteristics of good feedback actually are. So when we're looking at that, Hetty and Clark in their book, Visible Learning Feedback, they have different aspects. And what we tried to do is pick the ones that we felt were really mindful of what we were focusing on tonight. So the aspect of setting a goal is really effective when the goal is communicated that kids can understand it. Oftentimes, we are sitting there going, okay, well, we think our kids understand it because it's posted on the wall. It's posted on my board. I read it out loud. I had a kid read it out loud. But what happens when I walk into classrooms and I ask students what their goal is today, what the goal of the lesson is today, many of them cannot tell me what that is, nor what it looks like for them to understand or have mastered that goal. So ineffective feedback is when they don't truly understand what their goals are. So what we have to do is make sure that we create the environment where they can understand them. So giving them the power to help create that goal, whether it's an I can statement or a rubric that assesses whether they're mastering the goal or not. When they have the ability to help create those, then they have more of an understanding of what that is.
Then we go on to the kinds of feedback. Feedback needs to draw attention to that positive element of performance, not just the correct answer, but the details that follow in that correct answer. So like that student had that correct answer, I needed to focus in on, give me the details of that correct response. And that way we can confirm that our students are on the right path. Ineffective feedback is when you just solely are focusing in on the negative. Oh, that's wrong. Nope, that's not right. And if you focus on the negative all the time, students just get beat down. They lose that enthusiasm for learning. They're really going to shy away from wanting to participate. And so, we just need to focus on the, what's positive and the processes that make that successful. And some examples, again, it's just focusing on how did you come up with that? And also recognizing we can have different processes and respect those. And as they are mathematically sound, getting students to understand, hey, my method's a little bit different, but it works. And they're pretty proud about that. There's many times where I'll say to a student, I never even thought about it that way, but you are so correct in that method. And it was just, it's eye-opening even to me just to think that I didn't even think about it that way. And they came up with a good process. But again, focusing on that process with the correct answer.
Excellent. And so the third aspect that we wanted to focus on is that level of feedback, because remember, feedback is not about the person, it's about their performance. So it's about their performance surrounding a task, how well it was performed, how they might be able to do it more effectively. Ineffective feedback is when non-specific feedback is given. And I'm going to tell you upfront and honest, as a young teacher, and I know it's hard to believe, once upon a time I was young, okay? I was bad at this. I stunk at giving feedback. And my feedback was, Oh, Jan, good job. Yep, that's right. Awesome. Yes, on the right track. Oops, you're close, but not quite. And that was my wonderful, awesome feedback. And so my kids, I know, were just empowered to go do more because my feedback was so awesome. And as I grew as a teacher, I realized that that is not feedback at all. Good job. Good job doing what? Great. Great at what? You know, and that I needed to be very specific if I intended to change what was happening in my classroom with my students. So instead of just great answer like Jan gave you back at the beginning, she modeled, oh, yes, great. Wow, look, lots of right answers here. But great, good job, right answer. That's nothing. There's nothing behind it. So how about changing it and going, hey, that was a great answer. Like for my student, I really like the way you used your Inspire to show how to confirm the solution to your equation graphically. Now, when other students hear that feedback, they're going, oh, snap, I could have used my calculator as my tool of choice to have shown it. Oh, the teacher likes the fact that she picked up her calculator and used it. So other students are learning from the feedback that you're giving that one student. So we have to be mindful of the feedback that we give, and we've got to give very specific feedback if we intend it to be effective. So now, Jan, you get the big task of setting the stage for this part of it.
Setting the stage for feedback. And you think about your teacher actions. You know, we are so in charge of setting the atmosphere for our classroom and how the students are going to, you know, treat each other, collaborate with each other. We have to provide opportunity for our students to be able to and feel safe with that feedback. Like we mentioned earlier, having those, you know, those activities where no one is really wrong, you know, so we have to provide opportunities for that type of activities, as well as students collaborating with content and feeling safe and being able to comment on each other and give each other feedback, as well as students being able to accept our feedback. You know, there has to be a relationship between the teacher and the student so that I can go up to my student and say, hey, you know, I really like the way you have, you know, done your homework today. Can you explain number 5 a little bit more? And I want them to be comfortable to open up and talk to me and not feel like, hey, I don't want to talk to you, you know. And we've got to set that that collaboration, that atmosphere up in our classroom. We need to, as Sherry has mentioned earlier, we need to model the feedback that we want students to react, you know, use with each other. If students are listening to the way that we give feedback to students, then they are going to be giving feedback in that same way to their peers and maybe even back to us. So we are modeling 100% the entire time we are in that classroom on good questioning, good feedback, and just trying to improve, you know, success in our classroom.
Right. So taking teacher to student feedback, just looking at some strategies, and these are things that you already have stated and know, but we have to be able to avoid that comparison to other students. It's hard sometimes when we're in class that we get hung up and we start to say something and we have to really watch our faces and our mouths, and we have to avoid that comparison. But one of the things that we have to really do, Jan, is this. We have to check to make sure students understand the feedback that's given. And Jan, I know you happen to have a very good example of what happens when you check for that understanding and it didn't quite go the way you thought, right?
Didn't go the way I thought at all. And so this is kind of interesting. You know, they always said, and especially when I was a younger teacher, they always said, you will learn a lot about your teaching and your classroom if you were to videotape yourself. And there was a year that I was full on board with that. And I was, we're not closing up yet. I don't know why that went there, but I was full on board with doing a lot of videotaping, and I would focus in on groups. So my students were so comfortable with this. It was like no big deal to have a video going on in the room, and they probably didn't even know it was on their group. And so I go up to them and I'm going from group to group and checking in on them and making sure everything's okay. So I go up to this group and somebody asked a question and I answered it. And I'm like, okay, everybody got that? And you know what? Every single one of them said, yep, yep, yep. I said, you're sure everybody got it? And that's all I said. And they're like, yes, yes, yes. And you know how students just say yes, just so you'll move along. Well, so I went ahead and laughed and went on to the next group. And when I was watching the videotape later, what happened after I walked away was a student said, I don't get anything. She just said, will you explain it to me? So I learned right there that I did not treat that group and my questioning the way I should have as a teacher. Instead of saying, you get it? Everybody got it? Well, of course, if two people in the group say you got it, you don't want to look like you don't have it. So of course you're going to agree. Where a better technique would be to say, can you explain to me what I just said? Or can you explain to me how you would apply that to the next problem? If I would have asked for feedback from the students instead of just, a yes, no answer, I could have found out right then and there that one student did not understand. And most likely more than just one student did not understand. So it was a learning lesson to myself.
My wonder for you, Jan, is, and this goes out to everybody sitting here listening to this, is I wonder how many of us have done the same thing Jan has done and walked off to go to the next group to help the next group, not realizing that that student is back there saying, I really have no clue what's going on. And the only reason why you understood that is because you got to watch the video of what had happened. So I wonder how many of us have missed those instances in our own classrooms because we didn't take the time to dig far enough or ask the right questions. So student to teacher feedback strategies. There are so many of these out there, and this is something that we've talked about. So we look back at all of the things that we've done. We've looked back at getting students to talk through which one doesn't belong, notice and wonder, contemplate, then calculate. There's any number of things that we could use for strategies to get students to talk. But what we have to do is be mindful of the questions that we ask them. So we can't let students get by with saying, that thingy, Miss Abel, that thingy, that thingy over those two numbers. And we have to be mindful and we have to pull the right terminology out of them to make sure that they're adhering to the mathematical vocabulary that we expect them to use. So it's about our questioning that really elicits the student feedback response. So we have to dig oftentimes to get them to talk and to say the things that we need them to say in the right way. But notice if you practice this, and this is an ongoing thing every day in your classroom, that you are asking the right questions, eliciting those responses, and making sure that you're holding them accountable each time for what you expect to hear from them, they will rise to the occasion. And so that, there are a lot of things there, asking students to find a mistake on an example. Oftentimes teachers, I don't know about you, but I'm not perfect, but you probably are, but I'm not. And I would make a mistake in my math and we'd come out with the wrong answer. And in calculus, we came out with the wrong answer and it was like 2 boards worth of material. And I was like, okay, so your job is like to go figure out where I made the mistake, right? And I had left a delta off. That makes a big difference, just saying, in case you were wondering. But asking, like Jan said, students to re-explain the math step because we need to hear their thought process through it. Did they really pick up on what we were talking about, or are they just mimicking what we're saying? So place your answer in chat. Just quickly, give an example of a teacher to student feedback you have given recently in your in your classroom. Yes, Josh, those pesky deltas get me every time.
Yep. And kind of piggybacking on what Sherry was saying about mistakes, in my classroom, whenever a mistake is made, we always say, yep, that mistake is going to be a learning experience. It's a learning opportunity. It's expected, and we learn from it. So mistakes in the classroom, I always tell them we're going to learn because we made a mistake, and that's okay. And
Right.
so.
I know I've made a host of them.
Oh, yeah. I always like to make those mistakes where you know it's a common mistake, and then it
Great
becomes a
idea, Nat. I
discussion.
didn't think of that solution. Let's test it and make
Yeah,
sure it works. Oh, wow. Okay.
yeah,
To
yeah.
explain their thought process when they arrive at the correct answer, when they have done it a different way than I explained it. That's also great. I've learned a lot from my students getting their ways of attacking a problem.
I share my own mistakes when I went to
Yeah,
school.
sometimes I intentionally make mistakes to see if students catch them.
Yep.
Deborah, I would say that I made mistakes that I would tell them were intentional. How about that? So these are
Yep.
great ideas. How
Yep.
did you get this answer? Exactly, y'all. It's as simple as thank you, Kate, for being me. It's as simple as just making sure we ask how or why. That it's really easy to get at further detail if we ask that. So just another shot at this. What about student to teacher feedback you've received from a student? So how about some feedback you have received from a student? I love that too, Elizabeth. Nice job having
Yep.
their students use their calculators to determine if the answer is correct. That's beautiful. I do that a lot as well. I want them to be the owners of their work.
Can you walk me through your own thought process? There we
Mm,
go.
yes. Love that.
Yeah. Lots of good suggestions, lots of good stuff in the chat here.
Oh, I didn't understand that explanation. Can you explain it in a different way, Barbara? That I often get that with a student as well. And I think it's great that your student felt confident enough in your classroom that you've created that environment that they could ask for you to explain it in a different way.
Here's one on proofs. It's easy to get the students to instigate the next step.
Nice.
A student telling you, I think you made a mistake. Don't you love it?
I do,
I
because
love that.
what that shows me is that you've created the environment where students have the safety to be able to say that to you and know that you're going to take that feedback and run with it and not be angry with it. Because I see that happen as well, where teachers feel, oh, they caught me in a mistake and this is horrible, but this is not horrible. These are great, guys. Thank you so much for that.
Very good.
So the last little bit is student to student feedback, and we're trying to be mindful of the time as well. But providing feedback to each other is huge, 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 huge. Like we said, Hattie said 0.70 is what feedback gives. That's the effect size. It has an impact on student achievement. And the highest form of that feedback is being able to have students give each other feedback. And so they have to be trained to do that. We have to model that on a daily basis of what it feels like to give that feedback. And we've talked about this, and you've talked about this also in the chat, making sure that our classrooms are mistake friendly classrooms and that we all learn from mistakes. So, Jan, I know you've got some stems that you like to use with your students to help engage them in student to student feedback.
I think sometimes when students are in groups and collaborating that they have a hard time coming up with, how do I start the conversation? And this would be posters and things like this. I would have around the room. Sometimes I will post this, since I teach virtually now, I'll post this, as a reminder before the kids go to breakout rooms or when we're working together. And but these are some things like, I like how you did this. Can you go into detail on this? So these are just student, just STEM conversation starters. Think about the training that we had as teachers. Didn't we go through a lot of training where we would have like conversation stems or questioning stems? Like, what's a good question to use? So we need to train our students the same way. Give them give them a starting spot, is, could you show me how? Or I still have a question about, and then they can go on and say, factoring, but just some things that, especially for that shy student that really doesn't know what to ask. And, sometimes I very commonly say to students, sometimes we don't know what we don't know. So sometimes we can look and say, I see your answer, but I'm not sure how you got that because I did it this way, so there's different stems that you can put up around the room. And I would even have students go up and take a Sharpie and add to the list, which I thought was always great. So give them some stems, give them some places to start.
Exactly. So those are great ideas. One of the techniques that I used in my class to really kind of get students involved in giving student to student feedback when it didn't feel real to do it verbally, I would have them journal. So I would inevitably have a student who is absent. And I would say, okay, today you're going to write a letter to the student who is absent and you're going to explain the math that they missed today, because that way they can learn from that explanation and not be behind when they come back. So you can see an example of one of my journal entries where Pierre has written this letter to Billy about domain and range, something that we had studied that day. And what happens then is I collect all of the journals and then I randomly issue them to another student. And that student uses the success criteria that we have created for that journal entry, and they provide feedback to Pierre on his journal entry. And then that way, when I collect them all back, I then am giving feedback to both students, Pierre for his letter that he's written, and to Ingrid for her feedback that she's given, because I want them to be really good at giving each other feedback. And yes, the journal entry is a fun idea. My students love it and they engage with it, and they're not sitting there going, well, I don't want to tell them what I think. This way they're writing it. Plus I'm getting that writing and mathematics class down as well. And it doesn't start out pretty at all. I can tell you that. I can tell you that it doesn't start off perfect when you do it, but if you stick with it, it will become really, really great. So questions for you to ponder is, in your classroom, how can you get beyond the correct answer to assess student thinking and understanding? And how can you model feedback to students so you cultivate their abilities to give you feedback and other students' feedback? So these are things that we hope that you will leave with and think about as you go on your way tonight. But we do have some next steps for you.
So for your next steps, determine how you will assess students beyond the right answer, and determine how you will engage students in providing quality feedback to one another.
Right. And so this actually is the end of our presentation. I know that Mike has some information for you as well. And you can see that Jan and I have our details at the bottom if you want to reach out and actually email us if you need anything. We were happy to do that. And I'm going to turn this back over to Mike Houston to get us on our way for tonight. Mike?
Thanks
Oh,
so
I thought
much.
I put you to sleep, Mike.
I mean, what?
What?
No, it was
Wake
great.
up, Mike.
So we are going to begin wrapping things up, and if you caught Sherry at the beginning, she was excited about that one lucky winner tonight was going to win this TI graphing calculator, and tonight's lucky winner is Glenda Connolly. So Glenda, congratulations. We'll be in touch over email probably in about a week or so to get some more information from you, such as which TI graphing calculator you're going to pick. So congratulations, Glenda. To receive a certificate of attendance, go ahead and click the link in the chat window. Also listed as link for the documents from tonight. And if these links aren't working for you for any reason, just hang tight. You'll automatically get a follow-up email, which will contain a link to the certificate, the documents, as well as a link to the recording so that you can listen to this at your own pace. And if you're watching this on demand, go ahead and copy this link into your favorite browser to receive your certificate. If you need to get a hold of us for any reason, feel free to give us a call at 1-800-TI-CARES or send us an email, ti-cares@ti.com. When you leave the webinar tonight, a brief survey will automatically appear in your browser. Your feedback really guides us as we plan future online events. The event tonight that we did was different than what we normally do. Normally it's very technology focused, and this was really technology agnostic. So, it's exciting to get feedback from all of you because it really helps us figure out what you need in the future. So please feel free to be honest in that post-webinar survey. Huge thanks to Jan and Sherry for everything they put together for tonight. Thanks so much, ladies.
Thank you.
Thank you, and thanks for the participants in the chat room. A lot of good.
Y'all were
discussion.
awesome.
Yes.
I second that. There was some great conversations. I know one thing we were kind of worried about was that, you know, some of these conversations are sentences long, but that didn't bother anyone. Everyone was really, really great about typing those sentences in, and so it was just great. It was really good to have everyone on tonight, and we are excited to take 1 week off, but we'll be back at it the week after Labor Day weekend. So we'll catch up with everyone next Tuesday-ish. I believe it's the 11th. So we'll see everyone in a couple weeks. Have a great night and stay safe.